How are y'all? Morning. Oh, we only have 7 so far. I'll give us a few more minutes to let everyone get in. If anybody wants to tell me about like a really funny Halloween costume either you wore or you saw on Halloween, you can tell me in the room chat, or if there's just anything else you want to tell me, I would love to hear it. All right, well, we're going to go ahead and get started for today. I want to try to make the most of our time. So let's go ahead and, hey, Adler. We are moving on to a new unit this week. And the good news is this unit is actually our last unit of the semester. So once we get through unit 5, you will be done for the semester. The way that our schedule that I have it set up is we're going to finish all of the new lessons before Thanksgiving. Then you will go on Thanksgiving break, and when you come back, the only thing that will be due that week is your unit test and a small writing assignment, just like the part 2s we've been doing in Class Kick, and then you are done for the semester. So let's all just buckle down, try to make it to Thanksgiving. We can do it, okay? So we've got like 2-ish weeks of homework, 2.5 maybe, counting this week, and then your test, and you will be done. So that leaves you with basically 2 full weeks in December to do any makeup work, if you want to try to raise your grade, to redo like, I don't know, like writing assignments, anything like that. Okay, so just so you know, that's the semester. We have like, it's technically early release on Friday, December 16th. Good question. So this new unit, there's not really a whole, in the first 2 lessons we're going to do, there's not a whole lot that's brand new. It's still linear equations, which linear equations is what we've been doing in Unit 3. That's where we started linear equations in Unit 4. So what we're now working on is systems of linear equations. So that is where we're going to have 2 or more. Right, using my pen here. 2. Why is this not writing? 2 or more. And they're going to be on the same graph, okay, or describing the same situation. So today, our objective is that we can write a system of equations using 2 variables. So there are some steps to solving systems of equations. What we are going to work on today is steps 1 through 3. So we're just going to work on writing out the equation if we're given a word problem, or graphing. Okay? We are not going to work on solving until the end of the week, and that's what we will go over in our whole group next Wednesday. Okay, so today is all just steps 1, 2, and 3. I'm going to go ahead and read through these steps. Step 1 is we're going to be given a word problem, so sentences. We're going to read the problem several times if needed, until we understand what information we are being given in the problem and what information we still need to find. Then we're going to assign variables to represent unknown values. Okay, if we need to use a diagram or table, we can. And then we're going to write down what each variable represents. So for instance, if we were doing apples and oranges, we might say apples equals X, oranges equals Y. Then we're going to go ahead and translate the sentence into math equations. So that's writing the system of equations. Okay. Later in the week, we will do the solving part and then write the answer out and then check the answer. So here is what systems of equations, what the problem might look like from the beginning. A lot of you are probably used to reading these and just kind of freaking out. They do seem like a lot of information. Okay. It says, first of all, we're going to talk about finding dimensions of a shape. So this particular one is a parking lot. The problem says the length of a rectangular parking lot is 20 feet more than 3 times its width. That's the first part. The second part of our system of equations, so that would be like one equation. The second part says the perimeter of the parking lot is 800 feet. What are the dimensions? So let's read this again. We've got a couple different things going on. The first thing, the length of the rectangular parking lot. So length is 20 feet more than 3 times the width. That's like equation number 1. Okay, we'll just put a 1. Then we have the perimeter is 800 feet. That is equation number 2. Okay. What are we trying to find? We're trying to find the dimensions, which means we're trying to find length and width. We are not going to actually solve this today. Okay. The first part of your homework, which is in 5.01, it is all just about writing out the equation. We're not solving anything. So what we're going to do first is take a look at the blue sentence. Okay. And it says the length of a rectangular parking lot is. So we're going to say that L equals length. This is where we're labeling and assigning our variables. And we're going to say that width equals W. Maybe. Okay, so let's take a look again at this blue one. It says the length is. So anytime you have length and then the word is, you're going to use your variable. So L equals. Is the same as an equal sign. So L equals. L is 20 feet more than. So when we have more than, we're going to add 20. So 20 plus, okay, we're adding 20. 3 times width. So 3 times W. And that's going to be our first equation. So all I have done so far is I read through this blue highlighted sentence, and I wrote this sentence using variables and math in a math equation. So this says length L is equals 20 plus 3 times the width, or 3 times the width plus 20. 20 more than. Any questions about how I got any of that? Okay. Then the second part, highlighted in red, says the perimeter is 800 feet. So instead of writing our perimeter formula, perimeter is 2 times the length plus 2 times the width. You would have the formula for a perimeter on your star reference sheet. Okay. So instead of writing perimeter equals this, because we want to leave L and W there. Those are our variables. But we know what perimeter is. Perimeter is 800 feet. So instead of P equals, we're going to say the perimeter is 800 feet. So I'm going to plug in 800. So 800 equals 2L plus 2W. And that is it. That is the end of this problem. We wrote our equation. That is 100% it. So this would now be our system of equations, and then later this week we will talk about how to solve it. But for right now, we are just working on how to write them out. Okay, questions? Let's talk about if we are not given, we're not doing a problem with dimensions. What if we have prices, like money? So this is solving equations about prices of things. So at a local restaurant, the price of one soft drink and 2 hamburgers is $12.15. The price of 5 soft drinks and 4 hamburgers is $32.25. Find the price of a single hamburger and a single soft drink. So we are not actually solving this. Again, all we're doing is writing the system of equations. So we're going to read the problem again, and we're going to highlight the 2 situations that are going on. The first one is we've got 1 soft drink, 2 hamburgers equaling $12.15. The second is 5 soft drinks and 4 hamburgers equaling $32.25. So those are our 2 givens, and we're trying to find price of 1 hamburger and 1 soft drink. So step 2 says to assign variables. So I'm going to we'll let soft drink equal S. And H equal hamburger. So now all I'm going to do, that's supposed to say hamburger. All I'm going to do is go back to my original statement, the blue highlighted one, and I'm going to write that as a math equation. So 1 soft drink, that would be 1 S, that's an S, not a 5, and, so that's a plus sign, and 2 hamburgers, 2H equals 12.15. That's it. That's your first equation in your system. Then I'm going to go to the red highlighted, and I'm going to write that out. So 5 soft drinks, so that would be 5S plus, because it's 5 soft drinks, and 4H equals 32.25. And that is it. That is the end of our problem. Questions about how I got any of those numbers? Okay, we're going to try one more that's a little bit trickier because we're going to have 3 different equations instead of just 2. I'm going to cover this up real quick. All right, so let's go ahead and read this problem. We're probably going to have to read it a couple times, but that's okay. At a local bakery, a loaf of honey wheat bread costs $2.69. A loaf of sunflower bread costs $2.89. And a loaf of French bread costs $3.39. Okay, so we've got all of our prices. On a recent day, twice as many, so 2 times as many loaves of sunflower bread were sold as honey wheat. So the sunflower was 2 times the honey wheat. Okay, that's our second equation. Actually, that's technically our first equation, but you'll see how we use the first sentence. The next sentence says the number, exactly, Adler, there's 3 unknowns, and there's 3 different situations going on. Exactly. So the number of loaves of French bread equals 3 less than. So that's going to be minus 3 less than the number of loaves of sunflower. So sunflower minus 3 equals the number of French bread. total receipts for all those purchases was $96.58. How many loaves of each were sold? So you can see how these problems can easily from the beginning feel incredibly overwhelming. Okay, there's a lot of words, a lot of information, but let's just go back. We're going to assign the variables and then write each sentence in the problem as a math equation, just one sentence at a time. So we're going to assign variables. Let's go ahead and we're going to use X, Y, and Z. So we're going to let X equal honey wheat, Y is going to be sunflower, and Z is going to be French bread. All right, now I'm going to cover this up so it's not so confusing. Okay, let's read. The first sentence tells us the cost of each bread. Okay, we're not going to use that just yet. We're going to use that in our last equation. Okay, but let's go to the second sentence. On a recent day, twice as many sunflower were sold as honey wheat. Okay, so honey wheat, X equals, sorry, go back, not X. Yeah, okay, wow, that just erased that whole thing. Huh, okay, hold on just a sec. Okay, let's try that. Great, okay. So sunflower, twice as many loaves of sunflower were sold as honey wheat. All right, so that means whatever honey wheat was, X, we sold 2 times that many to equal the sunflower. So 2 times the honey wheat equals the number of sunflower. That's from this green equation, the underlined green. I'm going to put a green dot there. 2X equals Y. The second sentence says the number of French bread sold. So French bread, and it says was. So French bread equals Z equals 3 less than the number of loaves of sunflower. So that would be sunflower, Y, minus 3. That would give us how many French bread? And then finally, it says when the total receipts for all the bread was $96.58. So we have to add up the sunflowers, so X, but we have to know the price because now we're talking about price. So the price of the honey wheat was $2.69. So that would be $2.69 times X, however many we bought, plus however many loaves of sunflower, and those were $2.89 each. So $2.89 Y plus French bread, which was $3.39 Z. And all of that is going to equal, I should have moved this over a little bit, $96.58. Sorry, I hope you can read that. $96.58. So when we do number of French bread, number of sunflower, and number of wheat bread, and we multiply all of them by their costs, all added up, they equaled $96.58. So this one you would have 3 equations. Okay, what I want you to do right now is go to 5.01 homework on ClassKick.com. I want you to go ahead and log in. Open up 5.01 homework. Even if you already did it, that's okay. We're going to do the first one together. So I'm going to give you a freebie here. Yeah, of course. Let me give you the mic. Okay, I think you're
okay.
good.
So I'm kind of confused for the first system equation, 2x equals
Okay.
y. So it says twice as many loaves of sunflower was sold as honey wheat. How did we get
Oh, you know what? You're right. It should be
X?
2y
Okay, so I was like,
equals x.
man,
You're
I'm
right.
so
You're right.
confused on this part.
Nope,
Okay.
you're 100% right. Thank you. Two sunflowers equals the honey wheat. Yes. Thank you. Okay, yes, Adler, 5.01. Okay, so let me get my whiteboard up here. We are going to do, this is 5.01, and this is going to be slide number 3. Okay, so this problem says the sum of two numbers is 84. One number is 18 more than the other number. Write a system of equation that can be used to find the two numbers. Okay, so sum, what does a sum mean? What operation are we doing if we get a sum? Good, exactly, very good. We're adding. Okay, so if I add one number, we'll call it x, and another number y, I get 84. That's our first equation. The sum of two numbers, we'll let the two numbers be x and y. Those two numbers added together are going to equal 84. One of those numbers, it doesn't matter which one, you can let it be x or y. So x plus 18 is going to equal the other number. If I take x and add 18 to it, it will equal y. You could also have done y plus 18 equals x. It doesn't matter because it doesn't specify which number. And that's it. That's all you have to do for that first one, slide 3. Okay, so before you get working on that, I also want to go over 5.02. So if you want to go ahead and pull up your 5.02 homework in class Kick, we're going to do 2 examples, and then I will give you the rest of the time to work. So 5.1 was about writing the equations. 5.2 is about graphing a system of equations. We graph the system of equations because that allows us to find the solution. Okay, there's a couple different ways that we find solutions. One of the ways is by graphing. So there's 3 steps to graphing a system of equations. Step 1 is you're going to graph both equations. So you have to make sure that they're in slope-intercept form. Okay, they have to be solved for y so that you can plot the y-intercept and then use your slope. Then you are going to look for an intersecting point. If they intersect, that is your solution. And then you can check your solution. That's step 3. That one's kind of optional, but if you always want to make sure that you're 100% correct, you can check your solution by plugging in the value for x and the value for y back into your system. You would plug it into both equations and make sure you get a true statement. So I had said on step 2, look for an intersection. So when we graph a system, we can get one of 3 things happening. Okay, we have 3 types of solutions. We can have one solution. So one solution means the lines do intersect, which means they only, of all the points on the coordinate plane, they have one point in common, just one, and it's the point of intersection. Okay, we would write our solution as x comma y. They could also have no solution. No solution means that the lines never cross, and we call lines that never cross parallel lines. Okay, so if lines are parallel, they never cross, which means they have no solution. We know lines are parallel if they have the same slope. And then lastly, we can have infinitely many solutions. Okay, this just means that the lines are the same. So one might be multiplied at both sides by 2. But if you divided it again, you'd get that original equation. So you could have infinitely many solutions, which means every point on the line is a solution because it's the same line. So let's go ahead and fill out this slide. This is actually one of your homework problems. This is in 5.02, I think. Yeah, slide 3. Thank you. Mine's loading a little slow. But this is slide 3. So I'm giving you some answers here. Please take advantage of that. All right, so let's read the first one. It says, if two lines have the same slope and different y-intercepts, then the lines are, anybody have a guess? Same slope. What does that mean? But different y-intercepts. So not the same line. Good. Exactly, Noel. Parallel. Very good. The lines are parallel. All right. If one equation can be obtained from another equation by multiplying both sides by the same number, that's not 0, the system has. So basically this is saying it's the same line. If it's the same line, how many solutions would we have? We would have infinitely many solutions. All right. If two lines have different slopes and the same y-intercept, so it's telling you the y-intercept is where they have, is the only point they have in common, so they have one solution, then we would say the two lines, great, Amari, are intersecting lines. Exactly. The two lines are intersecting. Very good. And lastly, if two lines are parallel, the system has how many solutions? Means that they have the same slope, so they never intersect. Exactly. Good, Amari. AJ, no solutions. Now they have no solutions because they don't intersect. So a solution is where two lines intersect. If they never intersect, then they have no solutions. I'm going to pause here for just a second. If you didn't write this down or do it in class kick while I was going over it with you, just take a picture real quick so that you don't miss out on these answers. Okay, now let's go ahead and graph some of these together. So this is a system of equations. This is actually number 1 in your homework. If you want to do this with me, that would be really great. So we have two different equations. Step 1 is to make sure that they're in y-intercept form, and they are. Y is by itself. So I'm going to first, I'll do this top one in blue. I'll put a little blue dot here. I'm going to graph the y-intercept, which is -3. Now I'm going to use my slope to plot some more points. You'll probably have to plot like 4 or 5 points to find your intersecting point with systems. Okay, so you might have to use your slope more than once. So I'm going to go up 2 and to the right 1 because this is a slope of 2 over 1. So I'm going to go up 2 and to the right 1, up 2 and to the right 1. I can also go down 2 and left 1. And I'm going to draw my line. Any questions about how I got any of those points? I'm going to give you a second to do that on your class kick if you want to go ahead and do that. This is slide number 4 on your 5.02 homework. Trying to help y'all out a little bit. Okay. Now let's go ahead and graph this second line. I'm going to graph it in red. So my y-intercept is at +2, and my slope is -3. So that would be -3/1. So I'm going to go down 3 and to the right 1. As you can see, we already found our intersecting point. I'm going to go ahead and draw a line through them. And we're going to write our intersecting point, which is right here, this black dot. That's the solution. That's the one point that they both have in common. It's the one solution that makes both of these a true statement when we plug it in. So we're going to write it as xy exactly, AJ, and it's going to be 1, -1. Okay, so this graphing systems, it's not really anything new, right? You've been graphing lines since Unit 3. The only difference is now you're trying to decide, do they intersect or do they not? And if they do intersect, what is that point? Okay. So let's talk about what if they are not in slope-intercept form. I think this one is slide 11. This is slide 11 on your homework. So if they're not in slope-intercept form, meaning y is not by itself, we need to get them in slope-intercept form. So I'm going to put a red dot here at the top for the top one. I'm going to go ahead and solve this one for y. So I've got 2x plus y equals -4. And I'm going to solve for y. So that means I need to subtract 2x from both sides. And I would get y equals -2x minus 4. Any questions about how I got to get y by itself? Okay, let's go ahead and graph this one. So we're going to put our y-intercept at -4. Our slope is -2/1. So I'm going to go up 2 and left 1, up 2, left 1, up 2, left 1. All right, and I'm going to draw my line. Okay. Okay, now let's solve this bottom one for y. Okay, -2/1. Good question, Adler. It's just -2x, but I put it over 1 so that you could easily see the slope. So that means we're going to go down 2 and right 1 or up 2 and left 1. Good question. All right, so the bottom one, we've got x plus 4y equals 12. The first thing we're going to do is subtract x from both sides. 4 times y equals 12 minus x. If you want to switch the order around, I can do that real quick. That might make more sense for a lot of you. We can do -x plus 12. That's totally fine with me. Now I need to divide everything by 4. And when I do that, I get y equals -1/4 x plus 3. So let's go ahead and graph this one. I'm going to graph my y-intercept at +3. I am going to go down 1 and to the right 4. And then I'm going to have to go up 1 and to the left 4. And you can see our point of intersection there. I will put a black dot on it right there. So if we were to write out our solution, this point would be -4, +4. That would be our solution to this system of equations. Any questions for me? All right, so what I want you to do right now, we have 9 minutes left in class. I want you to log in to ClassKick. If you have not done 5.1 and 5.2, or one or the other, go ahead and use this time to work on it. I want to be in here so that if you have some questions, I can help you. If you are missing both of them, just choose whichever one you want to do right now, whatever one you maybe think might be tougher for you, so that I can help you if you have any questions. Good. I'm glad, Adler. Does anyone have any questions for me so far? Yes, Adler, let me go there, okay? 5.1, slide number 8. Yes, let me go to your slide here. All right. Let's get to it. All right, so a concession stand sells hamburgers H for $2 and hot dogs for $1. On Friday night, they sold a total of 300 hamburgers and hot dogs and made $420. How many of each did they sell? Okay, so first, we're going to look at this first one. The price, $2 and $1, is going to go with this last one, 420. Okay, so when we say, where's my pen? Here we go. Hamburgers, so the number of hamburgers plus the number of hot dogs was how many? 300, right? So hamburgers, just H plus D, those are just numbers, equals 300. Okay, now when it talks about money, that's where you have to add the price in there. So $2 for every hamburger, so 2H plus 1D equals how much money they made. So go ahead and write that second equation out. That is a really good question, Aiden. It means subtraction. Difference means subtraction. Adler, when you're finished with 8, will you come back to slide number 6 for me real quick? $2H plus D should equal 420. So remember that we want to do however many hot dogs times $2 plus however many hamburgers times $2 plus the hot dog price equals the total amount they made. So that all of that would have to equal 420. Okay, we got about 3 minutes left. Does anyone else have any questions so far on your homework? Yeah, Kiara, I will. Adler, let me know when you're ready to go to slide 6. Okay, I want to explain something to you real quick. Okay, Adler, give me just 1 second. And then Aiden, I'll help you for just a second. Hold on. Okay, Kiara, if you look at your slide 5, this top equation is perfect. Yes, Nola, give me 1 second. The second part says the steak dinner. So steak is 8 more than chicken. So this bottom one should be steak S equals chicken plus 8. But otherwise, your top equation is correct. Pennies, quarters, yep. And has 10 more pennies. So pennies plus 10. And then on 7, pennies is 10 more than quarters. So quarters plus 10 equals pennies. So check this bottom equation again. Yep, and you got number 8. That's perfect. Do me a favor, Kiara, raise your hand when you're finished so that way I don't miss out on grading yours. Okay, Adler, for number 6, the first thing says that the length, so you can let length equal X, that's fine. Let's just say length is X and then width will be Y. So the length, X, is, that means equals 12 more than width. So width plus 12. Okay. Or sorry, I guess that would be a Y. You were using X's and Y's. Okay. Perimeter is 120 feet. So perimeter, the formula for perimeter is 2L plus 2. Or I guess you would use X and Y. Sorry, I keep forgetting. 2X plus 2Y equals what number? And those would be your 2 equations. Okay, Nola, which number did you say? I'm sorry. I think you said 7, 8. Find it. 7. Okay. Yep, you guys are good to go. I'm going to help Nola here. And then if you have any questions, feel free to email me. I'm going to be out tomorrow and Friday. But I will try to get some of your questions answered this weekend. Okay, close, Nola. So this bottom one, this sentence here says 10 more pennies than quarters. So pennies is more than quarters. So quarters plus 10 would tell us how many pennies he has. So this should be Q plus 10 equals P. Yep. Okay, Aiden, let me see where you're at. So Aiden, come, if you go back to slide 3, this is the one I did in class that we did together. Okay, so I can put that slide back up real quick. Okay, we had the sum of two numbers equals 84. So when I add two numbers, let's say I have number X and number Y. X plus Y equals 84. That's how I get this first equation. So write that first one down. Then X plus 18, so one number, we'll call it X, is 18 more than the other number. Yeah, and I will check it. I'm going to have to go to a meeting here, but I will check it, okay? X, so one number X is 18 more than. So I have to add 18 to that number, and then I have Y. Wait, why did I put 2? Because Adler, the formula for perimeter is P equals 2 times the length plus 2 times the width. So perimeter means I'm adding all sides together. So it's length plus width plus width. And we just shorten it by saying 2L and 2 W's. Yep, good question. All right, guys, that's all I have for you. Have a great day, and I will see. Oh, yeah. So Tutor Me, I think you should just be able to click on the button, and there should be someone available, like, to tutor you. I think it's 24/7. That's what I want to say, but I guess I'm not 100% certain, but I'm pretty sure it is. Oh, Tutor Me.